numbers are a measure of something that isn't exactly correlated to what you actually know, right? You need to focus on mastering the content.
Pojo, welcome back to another MCAT podcast. I'm still licking my wounds from the last passage, and I'm scared. These seem so much harder than all the other passages I've done on Blueprint full lengths. And I've talked to people about this, about full lengths being, or diagnostics rather, being extra hard. What is your thought there?
Yeah, I mean, I'll be honest, I think diagnostic exams in general, if you think about what they're meant to do, they're meant to find what you are weak in, right? So they're probably, in terms of their purpose, going to expose you to the things that you're more likely to be weak in. So you can be like, all right, this is what I'm bad at. Now, when I'm done with the diagnostic, I can figure out how to improve each of those things that I'm bad at. Because I think I even tell students when I'm like teaching them and they make a mistake, like if you're getting questions right over and over and over again, you're not actually learning. You're just reinforcing the things that you've already learned, right? You're not adding new things to your brain and new strategies to your back pocket for when you need them. Yeah. So although it's really hard, I would just say it is a learning opportunity, no matter how brutal and painful it may feel at the time. Because I'll be honest, when I took my first diagnostic exam, I cried. I was like, oh my God, I am never going to do well on the MCAT. Like, I should just give up now. And I think knowing that it's a learning opportunity and knowing that it is going to get better, like this is the worst you'll be, ideally, in terms of your feeling about the test and your awareness of what to expect, I think that helps.
All right, so the diagnostic is there to tell you what you're not good at. Apparently, I'm not good at anything. So, with that said, let's go ahead and jump in. We're continuing our Blueprint diagnostic breakdown. You get it for free by signing up for a free account over at blueprintmcat.com. And we are on passage numero 5, I believe. So, let's go ahead and jump in.
All right. A key modulator of action potential firing is the hyperpolarization activated cyclic nucleotide gated HCN ion channel. These channels are permeable to both Na+ and K+. The HCN current, IH, is found in neurons under hyperpolarization of the cell membrane. IH is proportional to the frequency of firing of action potentials.
Okay. What do we like about this paragraph? It's a short paragraph. I like that it's basically only 4 small sentences here.
I was going to say, it's very small, and that's nice. We like that. And the other thing to note is that, again, like our last paragraph, it kind of talks about, last passage, it talks a little bit about like bio concepts, but think of these concepts as like MCAT relevant with a twist, right? So we need to know what action potentials are for the MCAT, but now we're being told about this modulator, right? So highlighting modulator of action potential can be helpful because that's a topic that's being introduced and it's specifically related to something we need to know on test day, right? The other thing I would mention is, again, because this is Chem Phys, because we're thinking about like chemistry and physics related concepts, I noticed that there's an ion channel. So HCN ion channel would also be something that I highlight there. The other thing I would highlight, again, like topics and relationships that are MCAT relevant are going to be crucial in passages like this. So highlighting the fact that these channels are permeable. So maybe the word permeable can be helpful because I know that, all right, sodium and potassium, they can go through this channel. And this new variable, HCN current or IH, is being introduced. And we're told that it's proportional to the frequency of firing of action potentials. And we don't need to know how, we don't need to know why. We just need to know that it is, right? So potentially like IH is proportional or something like that can be helpful there as well. But yeah, this is short, sweet, to the point. And everything in it is like, okay, cool. I understand this. This isn't making me want to like, exit the test and call it a day.
Yep. Okay. I see this keyword here, neurologist. So again, my wife is a neurologist, so hopefully I get this right. She'll be sad.
Oh, no way. All right. Neurologists wish to determine if a new drug, compound X, figure 1, is able to block IH and reduce neuropathic pain, providing significant analgesic effects to those with pain. And then we get like this nice figure.
So we have figure 1, the structure of lidocaine on the left and compound X on the right. So it's showing us kind of comparison. We know lidocaine. I think everyone should know lidocaine is an analgesic as well. Okay.
So one of the things for this paragraph that I want to point out is even if you don't know lidocaine, even if you don't know what an analgesic is, sort of like what you were talking about in a previous episode, Ryan, where we were talking about one of the passages and how students who struggle with advanced English vocabulary because their English may not be their first language, or because if they're like me, they're not very well read, you may struggle with that, right? But if you don't know what a word means, it doesn't mean you're screwed and can't answer the passage. It just means you have to rely on context. Yep. So based on the context you see here, we have providing significant analgesic effects, and right before we have this phrase, reduce neuropathic pain. So to me, as someone who may not know what that word means, I can say, all right, analgesic probably has to do with reducing pain. And that's not only spot on for what that term means, but also is all you really need to know. So for me, I would highlight either analgesic effect or reduced neuropathic pain, depending on which one I understand, right? And then I'd also highlight compound X and block IH, because again, this is one of my favorite things that happens in a passage when you go from conceptual to an experiment, right? The authors of this passage introduce these HCN ion only to talk about a new experiment that's being brought up, right? So highlighting compound X, highlighting blocking the IH, and highlighting analgesic effect would probably be what I do there.
All right. All right, moving on. And then again, noting, what would you note here in the figure?
I'd be like, cool beans. That's what lidocaine and compound X looks like. Let's move on.
Yep. Okay.
Compound X's effect on neuronal firing was first compared to lidocaine, a known sodium channel inhibitor. Ganglion cells were treated with 3 different concentrations of compound X. Sodium current was isolated and then recorded using patch clamping. Figure 2 shows the results of these recordings.
I'm trying to figure. I'm thrown off by the first sentence here where it's compared to lidocaine, but I don't see lidocaine unless lidocaine is the control, but I don't think lidocaine's the control.
Lidocaine is not the control.
Yeah.
And you're totally right. They just said that they compared it and then didn't really include it.
Didn't tell us anything about it. Okay.
Yeah, they're like, by the way, we did that, but then also we did this, and this is what we want you to look at instead.
Got it. All right. So, so ganglion cells were treated 3 different concentrations. So we have 100, whatever that concentration is, 30 and 1. Sodium current was isolated and then recorded. And so we can see the control, I'm assuming, is without any analgesic. You're getting this firing, which means pain is being signaled. And we want less than that. And so we can see with each decrease in dosing, different concentration, lower concentration, with the 1 of compound X, it's much closer. It's less than, but it's still much closer to the control. It goes down and down, with 100 being the least in this trial.
Yeah, the least similar to the control.
Yeah, so it seems like 100 of this compound X does a much better job of being an analgesic, if I were to make that assumption.
Yeah, no, for sure. I think another thing to note is just that general relationship, right? So inserting that compound X has an analgesic effect, and the more you add, the better it will be. So noting that there is some difference between the initial, the 1 micromolar, and the control is also important to think about as well, right? Mm-hmm. It's not like there's no effect until you get 100. It's that there is an effect, it's just it's not as strong.
Yep.
Yeah.
Okay.
in terms of that overall paragraph, I want to ask you, Ryan, what do you think is like the general, like think about the components of an experiment, right?
Yep.
Like the hypothesis, methods, results. What do we get in this overall paragraph?
What do we get?
Yeah, are we getting the hypothesis, the methods, the results?
We are getting the methods.
Yeah.
All right. It's just what are we doing? We're testing 3 different ganglion cells, or 3 different concentrations on the ganglion cell.
Right, exactly. And I think knowing what's being talked about in a paragraph, especially when it's related to an experiment, can help inform what you want to highlight, right? So because we're getting the methods of that in that paragraph, we'll see, all right, where in terms of what specifically we're measuring, we're looking at sodium current, right? So highlighting sodium current and recorded can be helpful. And in terms of the goals of the methods, we're looking to look at the effects of ganglion cells with different concentrations. So highlighting like ganglion cells, concentrations of compound X, something like that can be valuable as well. In terms of that first sentence, I don't know. They don't really talk about light chain, so like not super important to highlight, but you could say like X's effect on neuronal firing or something like that. But yeah, that's pretty much it. And again, I think one of the things that I recommend to people, especially in the beginning when you're struggling with the MCAT, is don't worry about time, but make sure you understand the general structure and layout of your passages, right? Because the MCAT is a standardized test. So as you continue to read more and more passages, you'll notice that a lot of them are more or less structured the same way. Yeah. So you'll have an intro of some topic, may or may not be related to what you know in terms of MCAT knowledge, and then they'll talk about an experiment and give you the methods and then the results. So being able to leverage that can help because it eliminates the unknowns that you get on test day, right? And it can help inform what you want to be highlighting when you get to each chunk of that like standard passage structure.
All right, moving on.
To test if compound X was indeed also a blocker of HCN channel currents, the effects of the drug on HCN currents in ganglion cell neurons was recorded. HCN channel whole cell current in neurons was induced by giving a membrane potential step from a holding potential of negative 60 millivolts step to negative 140 millivolts for 700 milliseconds and then back to negative 70 millivolts. Solutions of 5 milliliters were prepared with differing amounts of compound X. Figure 3 shows the concentration effect of compound X on HCN in neurons. And then we get figure 3.
Okay. So in this paragraph and in figure 2, they told us, hey, compound X is doing something, right? Because it's testing sodium current. So sodium current is being blocked. And now it's saying, okay, we know it's being blocked, but is it blocking this specific HCN channel? I'm assuming that's kind of going, that's where it's going towards here.
Mm-hmm.
Okay. All right.
So I will actually highlight that idea because, again, we're looking at the purpose of like a new experiment, right?
Yeah.
So I would highlight like compound X, blocker of HCN channels, because that's what we're testing to see if that's true.
Yeah. Okay. So then, channel whole current in neurons was induced. Blah, blah, blah. Solutions of 5 mLs were prepared with different amounts of compound X. All right. And so compound X, so it's a logarithmic, whatever that word, a log scale. Logarithmic. Wow. That's funny. So a log scale and of compound X, and then the change of whatever's going on here. Okay. What else would we want to see here?
So in terms of that paragraph, there are a lot of details, and I'll be honest, to me, that seems like fluff, right? So I would just probably note, all right, methods of this HCN experiment, right? And I'd highlight concentration effect, like figure 3 shows the concentration effect just because, again, it'll help orient me to figure 3 if I need to get oriented, right? For me, I struggle with those logs, so I'm just like, man, that's going to be a pain to figure out when it comes time to that. But knowing what it's showing can be really helpful. If you wanted to highlight the milliliters, because again, if I'm seeing like specific amounts of things in my MCAT brain, I'm immediately thinking like, okay, stoichiometry is probably going to show up in this Chem Phys section, right? So you can highlight that, but you don't have to.
Got it. All right. So what I'm taking away is that there's a change happening. So compound X is doing something to these channels.
Mm-hmm.
Okay.
Yeah, totally. Again, being aware of the fact that like just that figure itself is showing inhibition by adding, right? So it's very clear. All right, there's inhibition like happening. And when you go from left to right, you're adding more and more of that compound X.
Okay. All right. Logarithmic. There we go. This is what we're working on in the MCAT podcast today is pronunciation. All right. Question 23. Compound X and lidocaine can be separated using ether extraction because lidocaine is lipophilic while compound X is hydrophilic. B, compound X is lipophilic while lidocaine is hydrophilic. B, both molecules are hydrophobic with only non-polar groups. Or D, lidocaine is hydrophilic while compound X is hydrophobic. All right. So, I don't know. So when I think about what they both do, right? They're both analgesics, supposedly here, and they're both kind of acting in similar ways. And so to me, when I think about that, I go, well, can they be hydrophobic? Can one be hydrophobic and hydrophilic? Can one be lipophilic and one be not, or whatever? And still do the same thing, or will it prevent it from doing the same thing for the same kind of compound? And so again, I think I'd mentioned in the last episode, I tend to rely on just super basic logic, maybe a little too much for the MCAT. And I go, it's the same molecule, right? If I'm injecting some lidocaine in someone or compound X in someone, then I'm going to assume it's going to the same places, it's doing the same thing. So hydrophilic, hydrophobic, like it can't be very different, or else it wouldn't do the same things. I think maybe. So all of the hydrophilic stuff, so I'm gonna throw out, right? And so it's choice C. Both molecules are hydrophobic. Okay, great. They're both the same, hydrophobic wise, with only non-polar groups. And so we see from Figure 1 that compound X is much more complex theoretically, and so I'm gonna go with answer choice C as to why things are that way, but I don't know.
So here's the thing because you're totally right in that if they're going to have the same effect, they're likely going to do the same thing, same mechanism, etc.
Yeah.
But is there anywhere in the passage that actually told us that lidocaine and compound X did the same thing and worked the same way?
Well, kind of. They're both analgesics. They're both doing their thing. They're both, I don't know. Again, super basic logic.
Yeah, I mean, the thing is that, so with this particular passage, we were told that they were compared, but we weren't told about the results of that comparison, right? And with a lot of things in biology, like there's a lot of different ways to get to the same outcome. So for that reason, answer choice B doesn't it doesn't make sense to rely on the functionality of it. It would make a little bit more sense though to rely on the differences between them. Because if you think about what this question is asking us to do, right? It's asking us why there can be a separation between compound X and lidocaine. And for that reason, we need to rely more on what's different between the two rather than what's the same.
Okay.
So for that reason, I would urge you to sort of look at Figure 1, right? Figure 1, although it's kind of hard to do so over a podcast, but Figure 1 has the two different structures. One of them is our compound X. It has a ton of different charged compounds. There's a bunch of N's, a bunch of other stuff going on. compound, like for our lidocaines on the left, there's only like 2 nitrogens and a carbonyl, right? So if we're comparing the two, one of them is going to be a lot more polar, a lot more hydrophilic than the other, right?
Mm-hmm.
So our compound X is going to be what's more hydrophilic. Okay. So for that reason, answer choice A is actually going to be our answer, because in general, extraction is a method that we need to be aware of for the MCAT. And it's basically this idea of, if we put a non-polar solvent through a funnel that has our compound, like is going to dissolve with like. And so the non-polar parts of our solution is going to separate from the polar parts, right? So the answer really relies on us understanding one part is polar, one part is non-polar. So when we put ether in the mix, which is a non-polar solvent, it's going to separate. And so for those two reasons, A is going to be our answer. Answer choice C doesn't necessarily make a ton of sense, because the word only is a bit extreme here. Although lidocaine is non-polar, there are some polar groups in there, right? Like there's the nitrogen, there's the carbonyl.
Yeah.
It's just that globally, it's a pretty non-polar compound, because there's so many other, that phenyl group going on, that sort of dominates in terms of its overall characteristic.
Got it.
I think determining polarity and non-polarity is one of like the weirdest things to do, because it isn't black and white. Sometimes there are gray areas where, like, yes, there's a polar group in there, but that doesn't mean it's a polar compound, right? You have to think about like dipole moments and the overall structure. So if you guys, anyone who's listening is struggling with that, I would highly encourage you to just like look up like a video, look up blueprints modules, like do anything like that, just to confirm like what drives polarity and non-polarity. Based on the observed effects, what is the minimum dose of compound X required to reduce the HCN current to half the normal current? All of our answer choices are numbers. So answer choice A is 5 times 10 to the negative 4 micromoles. B is 1 times 10 to the negative 2 micromoles. C is 5 times 10 to the negative 2 micromoles. And D is 5 times 10 to the negative 2 moles.
Yeah. So when I look at this, I cry a little bit inside.
I was just about to say that. I was literally just about to say, like, do you cry on the inside?
I cry on the outside too. Based on the observed effects, what is the minimum dose? And so we're going down to figure 3.
Amazing.
Right? So that's where we're talking about HCN currents, which we highlighted here. And looking at half. So if we go here and here, like, is that half? We're trying to look at the negative 5 there. But that's a log. And so how do we get to moles? And you talked earlier about, 5 mLs, maybe we should think about that. So something tells me that you kind of knew what was coming. And it's been too long for me to figure out how I get from 5 mLs, and looking at this graph of this negative 5 on the log chart looks about halfway to getting an answer here.
Yeah, no, I think looking at the chart and being able to recognize, all right, the information that I need is in figure 3. And it isn't all of the information. We need to also look at the 5 mLs from the paragraph. That's, in my opinion, one of the hardest things to do for a question like this, right? Because I think half of the battle with answering questions that are heavily rooted in passages is being able to understand where in the passage you need to look, right? So the fact that you were able to do that is incredible, because if you just knew a little bit more about the stoichiometry, you'd be able to get this question right, I'm sure, right? The logic is what's really important for this question. That being said, I think the biggest thing to look at, right, is you need to combine the concentration that you get from the figure with the actual volume, because the concentration is just moles per liter, right? So based on dimensional analysis, all you really need to do is just find the molar, multiply it by the liters, and then you would get to your answer, right? So moles per liter times liter, that gets you to moles, right? Makes sense. Sure. So in terms of getting to that on this figure, now we need to do a little bit more digging into what this figure is telling us, right? So the biggest things that I like to tell my students all the time is pay attention to the figures in a stepwise manner. Don't try and just stare at it and assume the knowledge will just come to you like Jimmy Neutron brain blast style, right? Okay. Look at your caption, look at your axes, think about what's actually showing up here, right? So in our caption, we're told that inhibition of HCN currents by additions of compound X are being shown, and our x-axis shows the log of our X, y-axis shows the change. So it's clear that in terms of having the normal current, we're going to want to look at our y-axis, right? And our y-axis shows a delta I over IH max, which represents the change in your current as a proportion of the maximum, right? So it seems like for our y-axis, all we need to do really is find where on the x-axis is our y value equal to 0.5, right? And on this figure, it's -5. So all you'd have to really do there is, all right, see what value, like what number gets me to a log of -5, right? Do you remember how to do that, Ryan? I feel like it's hard. I don't ever remember.
No.
Yeah, it's hard. So for -5, we would just know, because remember, log base 10x would mean that it's going to be 10 to the power of whatever your answer is. So since it's -5, our X, our molar concentration, is going to be 10 to the -5 molar. Okay. Would you want me to talk through the math, or would that be really, I feel like it's hard to do it on a podcast.
Yeah, no, talk through it, because people are watching on YouTube as well, and so.
Oh shoot, my face is gonna be on the internet. Wow. Yeah. Okay, so what I would recommend you do is, once you get to that -5, we know it's 10 to the -5 molar concentration. We're not done there, right? We need to use our analysis with dimensional analysis. So we get for 5 milliliters. We can't just use that number, because remember, the units of molarity is moles per liter. Mm-hmm. So we need to convert our 5 milliliters to liters, right? Okay. And the biggest thing that I recommend you do when you're doing math on the is rely on scientific notation, because it turns ugly numbers into easier numbers. So instead of 0.005, you can have 5 times 10 to the -3 liters, yep. Right? So all you would do then is just multiply 10 to the -5 times 5 times 10 to the -3, and that would get you to 5 times 10 to the -8 moles. And at first, you're like, Pooja, what are you talking about? That doesn't match any of our answer choices. And I would encourage you to realize that all of the different units are slightly different, right? D is the only thing in moles, and it's wrong. It doesn't match our answer. Yep. Everything else is in micromoles, right? I'm going to be honest. This question could have been meaner. This question could have had answer choice B be 5 times 10 to the -8 micromoles or something, and you could have picked that, right? Yeah. But be very conscious of your units and make sure they're matching up. So at this point, all you have to do really is just convert 5 times 10 to the -8 moles into micromoles, right? And the conversion factor is that 10 to the 6 micromoles is in 1 mole. So all you can do is just multiply 5 times 10 to the -8, divide by 10 to the -6, and that will give you 5 times 10 to the -2. And that'll get you our answer.
Yeah.
I think talking through math makes it seem a lot more overwhelming than it is. But hopefully the idea of just multiplying those two numbers can be clear.
Yeah, definitely. Very clear. Very clear.
Now that I'm on the internet, I'm probably going to be more conscious of what I look like, what facial expressions I make.
All right. Question 25. How many chiral carbons are present in compound X? And so the first question I have is, what the heck is a chiral carbon? They're carbon atoms that are attached to 4 different substituents. So I obviously remember that. I did not just Google that. And so you're looking for carbons that are attached to lots of different things. And we're looking at compound X, which is this fun figure 1 on the right here. And so the question is, where are the carbons attached to 4 different things? And so if I'm going to look here, I'm looking at where is this going to be? I'm looking, and just at a cursory look, I'm not seeing where it's attached to 4 different things. Very briefly. So I'm going to say 0.
Yeah. Kill it. That's it. And the problem with this question is that most MCAT students, including myself, when you do a problem like this, you're like, it can't be neutral or none of the above. Like, picking an answer like that scares you.
Yep.
But I think the key is, like you just did, be confident with your glance. Be like, all right, I looked. I literally don't see anything.
Yeah.
That's the evidence I need to support my answer. Right?
I am smart.
I have eyes and I can see, I can count. So it's going to be A, and that's it. And I think you nailed that.
All right. Yeah, I'm not a big second guesser kind of person. I just go with it, and if it's wrong, it's wrong. If it's right, great. But I don't second guess, which is sometimes good, sometimes bad.
Yeah, I was going to say it's a double-edged sword for sure. But for the MCAT, I think it's a good thing because second guessing is often what leads people to falling for trap answers and for getting things wrong. So if you've studied, if you know what you need to do to solve the problem and you get to an answer, there's no need to really doubt yourself, right?
Yeah.
If an answer seems easy, it just means that you felt prepared. It doesn't mean that you're falling for a trap.
Yeah, and the Blueprint platform, when students sign up and they're taking full-length exams, whether they're doing a course or just doing full-length exams, the platform, if you're careful enough and are only picking answers when you're sure of your answer, and then you change your answer, the platform will tell you, right? In the analytics, it'll tell you questions you changed and got right, questions you changed and got wrong, right? That's part of the analytics there.
Yeah, I absolutely love the analytics section. I think, so for me, I used Blueprint when it used to be Next Step because I did the MCAT long enough ago that's what it was.
Yep.
But I wish I had an analytics like that. That would have been so helpful because I had to do it like the old-fashioned way and figure it out myself. But I think it's really nice that Blueprint's portal lets you do that because it helps you understand like where exactly your mistakes are. And if you're seeking additional help from a tutor, an instructor, or et cetera, you can provide like very clear metrics on like, this is exactly where I'm struggling. Can you help me? Or how can I help myself if I'm struggling in this particular content, right? Like one of the things that I do in my class is like, I show students an example analytics page and we sort of walk through potential solutions based off of what you can see. And that's something that you can do for yourself if you have that like analytics available.
Yeah. All right. Question 26.
How many grams of compound X, molar mass of 292.81 grams per mole, are required to create a 1.5 molar solution of the mixture used to test HCN current, as shown in figure 3? All of our answers are, again, numbers, which makes you want to cry on the inside. So you gotta do a little bit of math. Answer choice A is 0.0075 grams. Is 1 gram, C is 2 grams, and D is 6 grams. I know, Ryan. I'm so sorry.
See, so again, my strategy on a test would be like, which ones of these, being on the MCAT without a calculator, they're not going to be super evil. Be like, is it 1.1 or 1? Like they're not going to be that evil. So to me, 1 and 2 are too close to each other. And so I'm going to throw out B and C. And I'm left with it's either really small or it's big, right? 0.0075 grams or 6 grams. And the MM, what is that one again? What was MM?
Molar mass.
Molar mass. The molar mass is 292.81 grams per mole, which seems like it's big. And so I don't know. To me, that number's really big, and so I don't need a lot of it. So I'm gonna go with answer choice A just because of that.
Unfortunately, it's not the case.
Darn it.
I think that I do think that on the MCAT, there are going to be a lot of questions where the numbers are not going to be evenly spaced apart. So you're choosing B and C to eliminate. Makes sense in general, but unfortunately in this particular question, it is C. And I know. Wow. And the only reason to get it right is just to like do the math. So in terms of, I'm actually going to ask you, Ryan, if you have any idea about what information from the passage you think we would need to answer this question. Is there anything from the passage that you think we may want to use? So in terms of our like stoichiometry type stuff, right? Stoichiometry is generally like the conversions of grams, liters, moles, molar, whatever, right?
Yep.
That's like the broad field. So that 5 milliliters is coming up with great utility in this particular passage because we're going to be using that again. Okay. So whenever I notice that there's a math problem, for me at least, the solution never comes immediately. What I like to do is actually write out what I've been given and what I need to find. Because once I have that written in my scratch paper, like I literally write G, whatever we're given, F, whatever we found, that helps me understand what the next path is and also helps me determine if I can do it under like a minute and a half, right? Because if I just scribble it out and I notice that there are multiple steps that need to be had, maybe it's going to be something that I flag and do later if I have time, right? So for me, what I would do is write down what I've been given. So in this, we have the molar mass, we have the molar concentration, and we have the volume of our mixture. And in terms of what we need to find, it's just the grams of our compound involved. And we can tell that from the answer choices, right? So just like our last problem, this one really becomes a dimensional analysis problem where you convert from unit to unit to unit to eventually get you to grams, right? So we have our 1.5 moles per liter, right? Times our 5 times 10 to the negative 3 liters, right? Because remember 5 milliliters converts to liters. And then from there, we have moles, right? So to go from moles to grams, we would just have to use our molar mass. And that is just multiplying again. So we would multiply our answer of 1.5 times 5 times 10 to the negative 3, which is just 7.5 times 10 to the negative 3 moles, and multiply that by our molar mass. However, 292.81 times 7.5, I have no idea what that is. That's I won't feel like doing that. I don't. So I would round up to 300 and hope for the best, right? So round up to 300, multiply that times my 7.5. That's something I can do because it then quickly, we're using scientific notation, turns into 7.5 times 10 to the negative 3 times 3 times 10 squared, right? And the beauty of scientific notation is that what could have been an otherwise really ugly problem to do turns into, okay, group the numbers together, multiply 7.5 times 3, group the exponents together, multiply 10 times 10 to the negative 3 and 10 times 2, and do the math separately, right? So 7.5 times 3, that's 22.5. And 10 to the negative 3 times 10 squared, when you're doing scientific notation, one of the rules that you have to know is that multiplying the two is the same thing as just adding the exponents. So negative 3 plus 2, that's negative 1, right? So we end up with 22.5 times 10 to the negative 1 grams. And since everything is in our standard numbers, 20 times 10 to the negative something, that's going to be 2. And so that explains why 2 is our answer.
Yeah. Good to know. All right.
It's tough. I mean, I think one of the biggest things to know about these math problems is that there are a lot of ways where you can make it easier for yourself. So relying on rounding is going to be super important. So like my rounding of 292 to 300, the MCAT expects you to do that. The MCAT will give you an answer that is in line with that, right? They're not going to expect you to bust out your mental calculator and multiply 292.81 times 7.5. Like, that's ridiculous. No one can do that.
Yeah. Round. Definitely. Okay. Question 27. All right. So question 27, what alteration to an HCN channel will reduce the transport of K in favor of sodium transport? So potassium in favor of sodium. A, increasing the diameter of the channel by adding amino acids. B, decreasing the diameter of the channel by removing amino acids. C, replacing the serine groups in the channel with alanine. Or D, replacing the alanine groups in the channel with serine. So, this seems like a pseudo-discrete and has really nothing to do with the passage. Maybe?
I mean, yeah.
Yeah, maybe potentially. So the question would be, right? So we have the HCN channel. Again, HCN channel is this last paragraph that we're looking at. But it doesn't really talk about potassium, sodium. It just talks about all the normal stuff, right? Just the membrane potential. Mm-hmm. So if we reduce the transport of potassium in favor of sodium, I don't want to kill someone. Like, don't mess with my potassium and sodium pumps. Yeah. So answer choices A and B are, again, directly opposite. Answer choices C and D are directly opposite. Mm-hmm. So I'm left with two opposite groups. The diameter of the channel, I don't know if that really matters, right? You just have a bigger hole or a smaller hole. But if everything else works the same, I don't know how that will affect anything. So just, again, going to logic, again, overused potentially, I'm going to get rid of A and B. And now I'm like, okay, serine, alanine, I have to remember the potassium sodium pumps and what potentially is going on there. I'm tired at this point, right? We're only 5 passages into this diagnostic, and my brain has given up. And so I would choose C and move on, replacing the serine groups in the channel with alanine without understanding why or what, because I'm just like, can I be done? Like, my butt's tired. I've been sitting here forever working on this thing. And I don't know. I'm starting to freak out because the real test is twice as long as this. And oh my gosh, what am I going to do?
Yeah, I mean, I think the first thing I'll say is with the MCAT, practice is essential, not only because of the cognitive benefits that you have, but because it helps you increase your endurance, right? Mm-hmm. So like for me, it got to a point where when I was taking the MCAT, I finished an 8-hour test and felt fine. But that is not how I felt when I first started. When I first started, I literally couldn't physically finish. I was like, I am about to explode. Like, I could not finish it. I had to stop. Like, I felt so bad because I was like, oh my God, I had to stop halfway through. Does that mean I'm not going to be able to take the test? And just know that it gets better with every single trial that you do, right?
Yeah.
Like, if you think about the MCAT, I know everyone compares it to a marathon, but like it really is, right? So when you are training for a marathon, do you run like 10 miles on your first day? Like, no, you run a mile, then you run 2 miles, and 3 miles, and 4 miles. And then eventually you can get to like a half marathon with no problem, right? So although it's really hard, doing it a little bit at a time will be really important. Yep. The diagnostic, again, is just a way to expose you to what you're bad at. So if you're struggling to sit through 5 passages, it tells you that you should spend a little bit of time focusing on having long bouts of studying and having a lot of practice where you're doing, where you're exerting your mind like cognitively for long periods of time. So you can get used to doing that. And I think one of the things that I did when I got closer to my test that was actually really helpful is I studied in test-like chunks. So I studied for 90 minutes at a time, every like couple of days. Because for me, it helped because I got used to being mentally active for 90 minutes at a time because I had never done that before. I had always done like when I was in lectures and stuff, I would zone out after like a half an hour, right? Like I'd sort of zone out a little bit, come back in, zone out a little bit, come back in. But on testing, you can't really do that. So you need to train your brain to be that active for 90 minutes.
Yeah.
So that's like the biggest thing I'd say for that. For this question, I'm so sorry, Ryan, but like you got it wrong. And I think the main reason is because I think you didn't know enough about what was like the test was asking you about. So in general for the MCAT, right, every question is asking you about a scientific principle. Mm-hmm. And for this particular question, it's actually asking you about what is the difference between sodium and potassium, right? And I think the big reason why you didn't think about that is because sodium and potassium are actually chemically very, very similar. The only difference between them is actually size, right? So it's going to have to be between A and B. And I think the whole reason why I was like not certain by telling you it's a pseudo discrete is because technically speaking, the fact that the HCN channel is permeable to both sodium and potassium is provided in that first paragraph. But like, you don't need that to answer this question. You need to know the difference between sodium and potassium, right? So the key is the difference in that. And the difference between sodium and potassium is the size, right? Where potassium is larger than sodium, right? So if you were to try and figure out a scenario where unfortunately you're messing with sodium and potassium in a person who has pain, the way to reduce transport of something that's bigger in favor of something that's smaller is decreasing to the size to a point where it's in between sodium and potassium, right? The reason why A doesn't really make sense is because if it's a big channel, then it can bring in both. It's just that like there may be less wiggle room with the potassium when it goes through, but it doesn't select one over another. And so that's why B is going to be correct. Okay. The reason why C and D don't really make sense is because the difference between serine and alanine is polarity versus non-polarity, right? But because sodium and potassium are so chemically similar, if you change the chemical composition of your channel, it's going to do the same thing to both of them, right? So with a polar group, it's going to allow you to bring both of those two things in. But if you are replacing it with a non-polar group, you're not going to let sodium and potassium through.
Yeah.
Yeah. That's the main logic of that one.
All right.
Yeah. I'm so sorry.
That's okay. I can take it. It does not mean that I can't get into medical school. This does not mean that I can't be an amazing physician, because I've already done that, suckers. And that's right. That's the truth. Is too many students put the score that they get on their diagnostic or on their full-length exams or on their real tests, and they take that score to mean I can't or can get into med school. I won't be a doctor. I will be a doctor. I'm not a good doctor. I'm not smart. I'm not like I'm literally having a conversation with a student right now who's really struggling with the MCAT. She took it a second time. She struggled the first time, took it a second time, and went in with much higher practice scores, was out of her post-COVID fog that she had the first time, and still got a poor score. And she's like, I'm just not smart. I'm like, no, that's not what your MCAT score means. And it's such a brutal test, unfortunately.
It really is. And I think one of the biggest things that I tell people is it's actually something that I learned myself that really helped. And it's something that stems in pre-med culture, but can affect your grades as well. And it's this idea of don't seek to go for numbers all the time.
Yeah.
Because numbers are a measure of something that isn't exactly correlated to what you actually know, right? You need to focus on mastering the content, being able to truly understand and be able to explain it to someone else, and use strategies and whatever it may be to help you supplement whatever gaps you have in your content, right?
Yeah.
So if you focus on that and you improve on that, the numbers are going to follow. So when I talk to students and they're telling me about their scores and how there's plus or minus 1 or 2 point deviations, or their numbers are nowhere near where they want them to be, I tell them, like, listen, your numbers right now are going to be low. My numbers for the first 3 months of studying were like poop, right? They were just awful. I was about to curse and I'm not going to, but they were really bad. But once I got to a point where there was enough content that I understood, there's enough strategy that I was getting, the numbers started to follow. Mm-hmm. And I think you're experiencing a point right now where your numbers are really low. You just haven't gotten to that point yet. Doesn't mean you're never going to get there. It just means you haven't gotten there yet, right? So,
yeah, it's a very similar analogy to the to chopping down the cherry tree, right? You have 4 hours to chop down the cherry tree, and the smart person spends 3 hours sharpening their axe. And the other student is just banging away. I'm like, I'm gonna get a higher score. I'm gonna get a higher score. But like, no, just take a second, make sure your foundation's solid. We'll get there.
Yeah, no, I love that. I've actually never heard of that, but I like it. I may borrow it for my
steal it.
I'll steal it. Yeah, it's a good one. Again, I think it's true. For me, with my GPA and stuff, I didn't do well my first year of college, and it's because I was so focused on the numbers. But then once I started thinking about the actual content and learning things, that's when my grades started getting better. And I carried that with me to the MCAT, and I think I benefited from that.
Yeah. So it's an Abraham Lincoln quote. I'm pretty sure, and his quote is, "If I had 5 minutes to chop down a tree, I'd spend the first 3 sharpening my axe."
Abe Lincoln.
Yeah, smart guy apparently.
Yeah.